Hello, this lesson is pretty critical. I have a lot of students who do send me, ask the instructor questions about this lesson, but I hope that I can bring you through it so that you have an understanding. So it's about increasing and decreasing functions, and then additionally about piecewise functions. Increasing and decreasing can apply to all kinds of functions, but piecewise is a particular type. So I know this doesn't look like math, but this is an important concept to what we look at within increasing and decreasing. Every time we have a function or a graph, what we're going to do is consider that you are riding on this roller coaster from left to right, okay? And as you are riding on that roller coaster from left to right, you can talk about, oh, look, we're going click, 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 click uphill. That would be like increasing. And then whoo, downhill, decreasing. Then increasing again as you go uphill and decreasing. When we talk about whether or not we're increasing or decreasing or also constant, we're always going to consider on a function traveling it from left to right. And as we travel it from left to right, since we're mentioning left to right, that has to do with x values. Even though when we say we're increasing, we're actually talking about y values because that's like uphill. So we talk about the x's that make the y's increase and what x's make the y's decrease. Okay? Now at the moment when it turns, it's not doing either one. Okay, and you feel that on a roller coaster when you get to the top of the hill, click, 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 and then there's just kind of that lull moment when you're neither increasing or decreasing, and then it starts again. So we will never actually include the point. It will be an open interval where it turns, whether or not that's at the bottom or at the top. Okay, so this is a real informational slide. When you look at the function, then you have to consider that you are moving from left to right. And as you move from left to right, you're going to talk about, does it increase, decrease, or stay constant? Now, these intervals will always be open intervals because of the fact that when you're at the top of the hill or the bottom of the valley, neither one is happening. So you'll always use parentheses. They're always open. And they always refer to x. We are answering the questions with what x values make the y values increase, what x values make the y values decrease. And then constant is just when things stay level. Okay? So we've got examples down there at the bottom. So if you were looking at this, the point of turn right here is this maximum. But the maximum's x value is -1. So this one is increasing. Think of the x. It is increasing. It is headed uphill from -infinity to the x value of -1. Now, it seems a little bit odd, and that's really where a lot of people's difficulty is. You have to constantly remind yourself that although I know we have gone up to 5, you are answering about the x intervals. Come from the left, make sure it's open, and it's an x interval. And I call that LOX intervals a lot of times, from the left, open, and x. When we come from the left, and we are open, and it's an x interval, okay? So this one is increasing from -infinity to -1. Because even though it went all the way up to 5, the x value where it quit going up was -1. It is decreasing from -1 to infinity, which means from this -1 x value, as we go to the right, we're headed downhill. On this next one then, decreasing happened, and this is another thing that messes people up. The arrows always point out, but that's not the direction we're traveling. We're going from left to right. Okay, so from left to right, we're headed down. We go down then from -infinity, way over on the left, all the way to the x value of 2. Then we are increasing from the x value of 2 to infinity. This last one does not go up or down. It is constant all the way from the left, all the way to the right. Okay, so that's how our answers are going to look. This is like your instructions will say on your homework. Determine the intervals on which the function is increasing, decreasing, and constant. Increasing, decreasing, and constant for each one of these. So what I'm going to do is increasing, decreasing, and constant for each one. Now, these last two that look like just a jumble of lines, as well as this one that's not smooth, you would not want to ride any of these as a roller coaster. That would be a disaster. I get that. These are all the weird functions. They're all kind of weird. They come from those that I mentioned on the very first slide, piecewise defined, and we'll talk about how to get those graphs later. But these are piecewise defined functions, which means one piece of it might look like it's an x squared, and another piece looks like it's a straight line, and so on. So though writing this thing from left to right, if we start off, we are decreasing. So we decrease. Let's just go above where these turns are and look at where the x-axis gets cut. The x-axis gets cut at -1. And then since this value is 3, where we make another shift, it's going to get cut at 3. So we're going to have, and then we're going to cut it again here at 5. So those are all the different intervals where it's happening. So on this very first section of the x-axis, from -infinity to -1, writing it from the left, we are headed down. -infinity, -1. That's a decreasing section. Then from -1 to 3, writing this red line from the left, we are headed straight across, so that's constant. -1 to 3. Then from this x value of 3 to the x value of 5, we're headed up. So 3 to 5. And then from 5 to infinity, we are headed down again. Now, unlike domain, we do not put a union. If you put a union, it's going to mark it wrong. This is just a comma, okay? And I know that this is terrible writing using this tablet, but it's just a comma there, all right? Not a union. So from left to right, we have found all of our intervals there. Notice they are all open, and every single interval, it comes from the lower number to the higher number, okay? So left to right, open, and they're all about x. So here on our very first interval we see, it actually starts at -5, but even though that's a closed circle, our intervals for this type of answer are always open. So from -5 to -3, we're constant. Then this section, if we write it from left to right, we are increasing, so the x values are from -3 again, all the way to -1, because we're going to answer about x. So increasing -3 to -1. The next section we look at, writing from left to right, x values are 1 to 3, and we're headed down. So 1 to 3. And then from 3 to 5, we are headed up because we have to go from left to right. So that is increasing. Just put a comma from 3 to 5. Now I'm going to point out this note down at the bottom. If you did put all of these intervals together, it would be closely related to the function's domain, because the domain are the x values used, but it's not necessarily equivalent, because all of these are open intervals, and domain has closed intervals if the value is actually used. So don't think that this is domain, even though it's about x. This is a different sort of a feature, increasing or decreasing. Okay, our last one, from -5 to -2, we are decreasing. And then on the next little line segment, we have from -2 to 1, we are still decreasing, but that is a separate interval. Just like it's a separate little line segment. Then from 1 to 2, we are increasing. From 2 to 3, we are steady, which is constant. And then from 3 to 5, we are decreasing. All right, so we've talked about increasing, decreasing, and constant. Now, a function's graph can show maximums or minimums, but a lot of them only show a relative maximum or relative minimum, which means it might not be the highest point. So like this graph, well, both of these graphs, neither one of them has a maximum. They keep going up forever. The graphs also do not have minimums. They keep going down forever. So we a lot of times shortcut and call the top of this little hill a maximum, but it's technically a relative maximum, okay, or a relative minimum. And really that means that there's some area around it, it's taller than its neighbors, and it is called a mathematical neighborhood. Okay, so like if you only went in the neighborhood from -2 to 2 on the x-axis, that would be a maximum. But for the whole graph, it's a relative maximum. Same thing for a low point that's not, it's a low point, but it's not the lowest point. It's just lower than the points around it. That's a relative minimum, okay? Now, the reason we're pointing this out is because these points right here that I need, like if I needed to know where does this graph turn so I can distinguish between increasing and decreasing, I have to know the x values of those points. But as you can see here, these are actually kind of ugly little decimals. It's not, I would have looked at this with my, just looking at it and said, oh, it's at 0. So it's increasing from -infinity to 0. But we see here that it's labeled, it's not quite 0. It's close, but it's not quite 0. That point is just to the left of that 2. So how do we get those values? We're going to use graphing calculators to get those values. And then once we have the values, we can use those x points to talk about increasing and decreasing, okay? Because that tells me where that graph gets cut up. So for example, it is increasing from -infinity to -0.082. And then it is decreasing from -0.082 to 4.082. And increasing again from 4.082 to infinity. So we use those x values to answer those questions about increasing and decreasing, okay? But we're going to use our calculator to find them. So this says graph the function and estimate the intervals on which the function is increasing, decreasing, and find any relative maximum or minimum. So I'm going to bring up my graphing calculator, and I will share it with you, and then we will do those things, and I'll show you how to use the calculator to get those values. Okay, so I'll try to share as much of this at once as I can. We're going to get really close, and what I'm going to do is I'm going to type in x squared. So I've hit y equals, and then I have x squared. I can graph this. Oh, my window is not normal. Anytime you need to adjust your window, you can hit zoom 6. That goes to a normal -10 to 10. And so then this is that turn point. So from -infinity to this x value, and then this x value to infinity. So I know that that's at a 0, but if you don't know where it turns, what do you do? So we tell it to second trace, which you can see up above trace. I know that's awfully small, but that says calculate. Okay. and I want it to calculate a minimum. Now it is a 0 in this case, but rather than worry about that, we're just going to say calculate a minimum, because they're not all going to be zeros. They will all be minimums. Then always your calculator, don't worry about where it's blinking. That's not really the critical thing. It's left bound. It will always ask you left bound. And you're going to use these, the left and right keys, whichever one you need here, to move to the left of that minimum. So it doesn't matter exactly how much you move to the left. You just move a little to the left and hit enter. Then it switches to right bound. Move a little bit to the right and hit enter. Then it asks you to guess. You actually can skip that. It doesn't save your calculator anytime, so I'm just going to hit enter again, and bam. It tells me what this minimum is, but I need you to look closely at this and be very aware. If you see e to the negative, and you get out there at about -3 or 4, that number rounds to 0. And our calculators are just not quite precise enough to tell you that, okay? But that is -2 point, but that's got, when it says to the -6, that means you need to move this decimal 6 places to the left, which means you've got 0.000002. That is approximately 0. So that point on that graph is 0. So that's where it's going to cut my x-axis. So again, I'm going to be decreasing from -infinity to 0 and increasing from 0 to infinity. So I was decreasing from -infinity to 0. And then I started increasing from 0 to infinity. So it asked me to put the increasing first, but that's not necessarily what I filled in first. There was no place it was flat, so this one does not exist. Okay, or they might call that the empty set. And the minimum, that low point, was, it was 0, 0. And what generally we say is that, I'm going to write out here what the point was. It is 0, 0. But when you're looking for this, you're going to look some for the wording. And we're going to say the relative minimum is 0, and it occurs at 0. And whenever you're writing that, the minimum or maximum is the y value, and it occurs at the x value. Now, we could do that in a different order, but at x. So at 0, it is 0. And that phrasing is going to help you know how to fill it in sometimes, okay? But yet the point itself is the point 0, 0 if they ask you to put it in an ordered pair, okay? Because there's 2 ways to refer to those. All right, so let's get our graph back over and let's do our next problem. So y equals, this one should be 4 minus x squared. Now I could totally type over, but since I just need to insert something in front of it, I can hit second delete, which is an insert feature, and then put 4 minus. Go back and look at my graph. It has turned it over and moved that turning point, and it's moved it up 4. Okay, but if you weren't sure, and again, I'm just kind of teaching you to use your calculator also, this time that's a maximum. And so we want to move to the left, move to the right. If your graphic calculator doesn't draw those vertical lines, I totally get it. They don't all, don't worry about it. And this one, it was able to do better. At least I got the 4, but this still rounds to 0. So that point is 0, 4. So 0, 4. By the way, this one was a minimum. This one is a maximum, relative actually. If I wanted to fill this in, the maximum is 4, and it's at 0. Okay? Now, while this one, let me put a little sketch beside these, look like that. This one looks like this. So it's going from -infinity to that x value, and it was increasing -infinity to the x value. That finished up that hill, and then it turned around and started going down from the x value to infinity. And once again, this one did not exist I'm just going to put dashes this time. It'll be a little bit less writing. So you can see those answers there. I put by comparison, negative infinity to the x value of 0, 0 to infinity. Okay, let's look at our next problem. I'm going to go back to my y equals. I'm going to just hit clear and type in 5 minus the absolute value of x. 5 minus. Now, where is that absolute value? How do you put that in? We'll go to math and then go to the right under your number menu, and you see this ABS that has parentheses. That stands for absolute value. Older calculators actually do still put parentheses with abs in front of it, but the newer ones make it look like an absolute value. So that's 5 minus the absolute value of x. And I go to the past that to get out of it. Now I'm ready to graph. So again, that was under, we'll see it on the next one, but it was under math and then over to number. So this one then looks like that V that heads down. I'm going to pick up a little bit of speed. We could solve for that, but I happen to know that point is 0, 5. Okay, so that point is 0, 5. So I'm going to be increasing to 0 and then decreasing after 0, because 0 is the point on the x-axis when I'm talking about increasing and decreasing, but yet that maximum is 0, 5. 0, 5. It was a maximum. That means that my maximum is 5, and it occurred at x equals 0. The shape of the graph up here by the number 19 was kind of an upside down V, which means I was increasing first from negative infinity to 0, and then I was decreasing from 0 to infinity. So my maximums were different, the shape of the graph was different, but the increasing and decreasing intervals were actually the same on those two. Okay, so if we graphed this one, and you can pause this and put it into your own graphing calculator and look at it, but the maximum, the minimum, because this low point right here occurs at -3, -5. Because it is a low point, it is a minimum. Okay, and so that minimum is -5, and it occurs at -3. Now, since I know the shape of the graph, then I know that I started off decreasing. So I decreased from negative infinity to -3. And then I turned and increased from the x value of -3 to infinity. And once again, neither one of these, I may not have any that have a constant area. There are, that's where it's straight across, and that's just not as common. It can happen, but it's not as common. Okay, so 21. 21 is going to go up. 22 is going to go down. So then the question, I know that because of that, this first number being positive, this one's negative, but so the question becomes, where does that turn happen? Okay, that occurs at 3, 1. So on number 21, the point was 3, 1 because it was a low point. Boy, that sure didn't look like a curve. It was a minimum. The minimum is 1, and it occurs at 3. Now, traveling this on number 21 from left to right, I'm decreasing first. So I'm decreasing from negative infinity to the x value of 3, and then started increasing from 3 to infinity, and the thing was never level. All right, guys, one more of those, and it tells me it's at -4, 7. So this is our last one on this, -4, 7. That's a maximum. So again, the maximum is 7. It is at -4. Okay, depending on which way they ask the question. And then traveling, I'm going from negative infinity to that x value of negative 4, and I'm increasing. Negative infinity to negative 4, increasing, and then negative 4 to infinity, I was decreasing. So again, I see that we don't have any sort of a thing there that is constant. But don't forget, a constant has to be a section like this that is headed directly from left to right, and that's simply less common. Okay, so moving to our new concept, then we have piecewise defined functions. And that's where, again, we use different pieces and we break the pieces up by their domain, by the parts of the x values we're going to use. So rather than graph this one, what we're going to do right now is simply look at how to distinguish which piece you're on. So if it says find f of negative 5, and I'm just going to write this underneath here, f of negative 5. It's as simple as saying, okay, my number I'm plugging in is negative 5, so x is negative 5. Then you go over here, and these are domain sections. So all of this part is actually the domain. You need to figure out which part of those domains negative 5 fits into. Well, it fits into this first one, which means my equation is x plus 1, which means I have negative 5 plus 1, and so I get negative 4. So f of negative 5 is equal to negative 4. Then if I've got f of negative 3, first thing you want to do is figure out, well, which domain does negative 3 fit into? Well, negative 3 is still less than negative 2, so it still fits into the domain for x plus 1. So now I have negative 3 plus 1. The answer to that is negative 2. So f of negative 3 is negative 2. F of 0, what is the domain for the 0? Well, 0 is between negative 2 and 3. So the equation I'm supposed to use is 5, which means there is no work to do. F of 0 is 5. It's just that simple. My next one, f of 3. Okay? So 3, well, I see 2 3's here, but notice this middle one that says or equal to. So it's the middle one that I have to use. So the equation I need to use is 5. So again, there is no work. F of 3 is equal to 5. All right, f of 4. 4 is bigger than 3, so the work I need to do is x squared, which means I need to do 4 squared, and I get 16. F of 4 is 16. Now 10 is also bigger than 3, so when I plug in my 10, I'm on this last row, and I still need to do x squared, which means I've got 10 squared, which is 100, so f of 10 is 100. Now, we've only done a few values here and there, and you will have some problems like that, but when you're actually going to do a complete graph, what happens is that we're plugging in number after number after number. You know, it's all of these values, so things start to get connected in areas. Now, when you need to graph, it certainly is different online. If I wanted to do just this top row, the top row would be an equation that said x is equal to 4. Okay? So x is equal to 4. 1, 2, 3, 4, which means I would need to graph this horizontal line there. Now, we know I can't draw a horizontal line, so I'm going to see if I can insert one. And I'm going to go up 1, 2, 3, 4. However, going back to domain, I know that x equals 4 would be this line, but I'm not supposed to draw the whole line. I'm only supposed to use the part less than or equal to 0, which means my line here is too long. I cannot start it anywhere except for at 0. I'm so sorry, guys. I don't know if it's a storm outside or what. So that is the first part of this graph. Now I'm going to go ahead and do the third part because it's also a line. And that would be kind of handy for me. This last part's a curve. This middle part, rather, is a curve, and that's going to be a little bit more difficult. But this is a line. So 2x minus 6 would start at -6. Okay, it starts there. And it has a slope of 2. Okay, so you can see I'm dragging this out, making it nice and long where it's got a slope of 2. So this is what it would look like. It would keep going, but this is too big because if you look at my domain, I was only supposed to start this where the x is equal to. So I'm going to go over here. This is where I should be starting that graph in. It should not be that entire graph. It's only the part where equals there. So on these, with the domain, since it can equal 0 on my first piece, this one is a closed point. On this last piece, though, it said x is greater than 2. So that should actually be an open circle right there. And what I'm going to try to do in the middle, and this is going to be difficult with this curve, is look at this graph. Okay, now I can just kind of plot some points along the way here and figure out where it goes. You could use your graphing calculator to help you. I know that this is going to be a curve that opens down, and then the point of it is 4 high. But what I'm going to do is I'm going to say, okay, this graph was supposed to start with an open circle at 0 because it can't equal 0. If I plugged a 0 in here, I would get 4. So this graph starts at 0, 4, and it would have been an open circle, except for that point is already filled in. Now let me plug in a 1. If I plug in a 1, then I get 4 minus 1 squared, which is 4 minus 1, which is 3. So when x is 1, I've got to hit this point right here. What about when I have a 2? 2 squared is 4, so that's going to be 4 minus 4 is 0. So when I plug in a 2, I actually get this one, and it is closed right here. So if I could draw this smooth, what it would be is like part of one of those parabolas, part of a horseshoe sort of a thing, but I'm sure I won't be able to do it very prettily on here. Well, I have done a lot worse before. Okay, so this one is the part where it said x equals 4. This part was 4 minus x squared. And this line over here that's headed up and to the right is the 2x minus 6. The reason they don't go continuously is because of the domain. If you look at where we have cut up, this first one stopped at 0. So that was x is less than or equal to 0. And then we also went from 0 to 2, and then from 2 to infinity. So our domain sections help us figure out how to graph it. Now, when you are online, you're more than likely going to just get to choose the correct graph, which is easier, but you still are going to have to look very, very closely at the open and closed circles. And let me correct that. I know that online, sometimes they will show you these graphs, and what they actually have, they have you do is write the equations. Okay, I have a little note down here, holes occurs when factors cancel in rational functions. I'm a little bit disappointed that there's a problem or two like this on your homework. But what happens is that where x is equal to -2, this is undefined. However, this graph looks exactly like the graph would if we reduced it, except for the hole. So unfortunately, we've got to go ahead and deal with that a little bit. So I'm going to take that top section down here, x squared minus 4 over x plus 2 is the same x squared minus 4 factors Now, what we know is that x can't equal a 2. These would cancel. That's what the note's about. The whole occurs when a factor cancels. So I know x cannot equal -2, but the fact that those canceled actually tells me something extra about it. I know that this value is a whole. Where does that whole occur? Now that it's canceled, this graph reduces to x minus 2, which is a line. Well, I know this fraction at the front ends up looking exactly like this line except for the whole. So if I can figure out where to put this, then I can figure out where on that graph the whole is. Now I'm supposed to use every value there except for -2. So just kind of placing it out, if I needed to graph x minus 2, it would start at -2 on the y-axis, and then it would have a slope of 1. But what's going to happen is I am dotting along and I'm graphing where that line's going to be. At -2 for x, that graph actually has a hole. Okay? So I'm not going to be able to put that one in. So when I go and I put in my shape, I get this one. But then additionally, the other part of it, oh, I should have made it a little bit longer, goes to here. So really what I'm trying to say, and again, I wish this would be so much easier if we were in person, but there is a line that has a hole in it where x is -2. Okay? So that takes care of the top one. Now, if you were to graph this top one on your graphing calculator, you can't see the hole. That's one of the weaknesses of your graphing calculator. It would show you the line, but you're only going to know there's a hole there because I'm telling you, holes occur when factors cancel. Now, additionally, where x is -2, there is a value. Where x is -2, we should get a value of 3. -2, 1, 2, 3. And so we should have a steady point there. Now again, you are going to be identifying the correct graph or trying to fill in these parts of it from your online homework. But there are some application problems. So just a couple of examples to help you with application problems. If you are going to, if you read something that says express blank as a function of blank, okay? For example, a rectangle's width is twice its height. Express the area as the function of width. Whatever it tells you to express at such and such, to express area, the area is going to be my y value, okay? As a function of whatever that is your x value. That means my area, first of all, the width, area is normally, for a rectangle, length times width, or in this case, width times height. But it says the width is twice the height. If the width is 2 of the heights, that means the height, what this actually means is the height is half the width. Now the reason that's important is because I have to use the function of width, okay? So I'm going to say, okay, well, my width is still my width, but my height is half of my width. So I could say my area as a function of width is equal to 1/2 the width squared. Okay? So whatever your function label is, it is a y value, but since they said area, I labeled it area. Since it said a function of width, that's why it's got this little w in here. And that lets you know the only variable you can use, which is like your x value. Okay, let's look at one more. Two nurses, Kiara and Matthias, drive away from the hospital at right angles to each other. Okay? We've got Kiara's speed is 35 miles per hour. Matthias' speed is 40 miles per hour. Express the distance between the cars as a function of time. The distance then essentially is like my y value, so it'll be distance equals. Time is going to be my x value, so that's the number I'm plugging in. So my distance as a function of time will equal. Now let's think about this for a minute though. In general, distance is equal to rate times time. Now they drove away from the hospital, which over in this picture is at that intersection, and they are headed different directions. But I know that as Mattia travels, and it says it right here, it is 40 miles per hour, so it's 40 times t. That is rate times time. As Kiara travels, it's 35t, because that's her rate times time. So how do we get this? Well, that is a right angle, which means this is equal to the distance, okay? The distance of this right triangle, that hypotenuse, you might remember, is a squared, because this is really our distance right here, so it's the hypotenuse. The hypotenuse of a right triangle is a squared plus b squared equals c squared whenever your hypotenuse is c, just so it doesn't matter about those, but we have a squared plus b squared is equal to c squared. But if I want c by itself, then that means I have to take a square root. So this one's really kind of ugly. So we're going to have a square root of 40t squared plus 35t squared. And it might let you stop there on your homework, but it depends on how simplified they want something. Like 40 squared is 1,600, so this would be 1,600 t squared. 35 squared is 1,225, so 1,600 t squared plus 1,225 t squared. Of course, that's all still underneath that square root, which we know I can't draw very well. So 1,600 plus 225 is 2,825 t squared. Which means if you knew how long they traveled, this would be the equation you plugged it into. So this is your function of time. Now, whether or not you're going to need to know the formula for the length times width, width times height, or you're going to need to know the formula for the hypotenuse of a right triangle, the Pythagorean theorem, you know, that's just kind of hit or miss as to whether or not you know those. And I'm sorry to say that, but don't hesitate to look up a little formula for something. The practice that you're really trying to do is rewriting things in terms of whatever they say function of. So here they said a function of time, everything that had to be written with the only variable as t, like our plug-in value is t. When everything is, if it's a function of width, then the only variable you can use is whatever variable you write for width. And they're very likely in the problems online to give you a letter and tell you whether or not you should use X or you should use W, okay? But I think that little phrasing will help you. Just before we get out of here then, if you'll just bear with me for a minute, I'm actually going to go to the homework and I'm going to bring up one of those piecewise defined functions from your homework and kind of show you how that's going to work on your online homework, and then we'll be done with this lesson. Okay, so here is one example of a homework question, and here they have the function they simply ask you to pick. So what I know if that's definitely a lot easier. If x is 2, it should equal 6. So these need to have the point on them, 2, 6. But if you look, they've counted by 2s. Every single one of these graphs has a point on it there. However, you cannot have one point directly above the other one. So A is out, because if this is the point that I have to use, this has to be a hole. Now B would be a possibility. We'll come back to that one. C is possible. D is not possible because it does not have a hole. So I've narrowed it down to 2 of them. So in order to figure out which one of these it is, the easiest thing for you to do is to graph this in your graphing calculator. If you factor it and reduce, so it comes out to the equation, the x minus 2's cancel and you get x plus 2, which means it would have to have a y-intercept of 2. And that's going to be option C, because B does not have a y-intercept of 2. Okay. Determine domain and range and write an equation. The domain is all the x values used. So it starts here. Let me make this nice and big for us. It's from -9. And then it seems like it's open here, but we're looking at x values. So if all of this could get squished to the x-axis, it would cover everything from -9 to -2, but then that little straight part would cover from -2 to 0. And then beneath it would cover the part, that last leg that's headed up would cover from 0 to 4. So it actually uses all the x values from -9 to 4. Now what is the range? The range has to do with y values. So if we look at this again, it's like if you squished all of this to the y-axis, what would it cover? And I want to go from least to greatest. So it's open at -10. I'm going to pay attention to that now. Open at -10. And then that leg goes to here, but by now I'm already on this left-hand leg. And it keeps going all the way up to 9, but it's open there. So, excuse me, it is open from -9. I may have said -10 a minute ago. From -9 to 9, and it uses all those values in between. Since it's not a single number, the range is an interval. This one piece would give me a single number, but each of these is all of those numbers, so it should be an interval notation. So the range is interval notation, -9, and it was open there, and then all the way up to +9, and it was open there. And this is the part I was really wanting to show you. This is where you're going to have to fill in some different sections for this. So one thing I'm going to point out is you have 3 different pieces. Since you have 3 different pieces, automatically choice D and choice C is out. You're going to have A or B, so you can have 3 different pieces. The next thing you want to do is consider how those pieces break up the x-axis. So I'm going to make this big again. And as I make this big again, what we can see is that the x-axis gets broken up into -9 to -2, and then from 2 to 0, and then from 0 to 6. However, this one in the middle, it is closed on both ends. It is an interval from -2 to 0, and it's closed on both ends. So if you look at A, this was only for x to equal a specific number. When x equals a specific number, that's where you've just got a dot. But here I had a line. So that's going to be this one. It went from -2 to 0. And the fact that I said it's closed on both ends is why this says or equal to. All right? This one, I mentioned it when I had it bigger earlier, that goes from -9, and it's closed there. So that's what's going to go into this one, -9. And it goes all the way up to the -2, but it's open at -2. This last section goes from 0 on the x's, and it's open at 0, so that's why it's a strict inequality, all the way up to the x value of 4, but it can equal 4. All right, so I have filled in the domains. Now what I want to do is figure out what that line is in each one of them. This very first line, we're going to have to make it big again so that I can continue. In order to get that lines equation, what I can see at a glance is it has a slope of 1. But I wanted to think, okay, well, what would the y-intercept be? The y-intercept would be right here. So that would be 11. So the equation of this line is x plus 11. Oh, 112, 11. Okay, what about the equation of this line? Well, it's a horizontal line, so it's just y equals the number, and the number that y equals all the way across there is 5. So y equals 5. So I just put a 5. Then our last part, I need the equation of this line. Y equals mx plus b. The b value is down here. Don't worry that it's open. That's why we put the domain on there. But this is at -9, and it has a slope of 3. So it goes up 1, 2, 3 when it goes over 1. So this one is going to be 3x and then -9. So what I had to do, again, is look at, I had 3 sections, so I knew I needed to use either A or B, because if you look at choices C or D, they only had 2 sections. Then I figured out which one of these it was based upon the domain. You can only use an equals if it's a single point. And something where it's strictly less than or greater than would be something that kept going in every direction. Since this was line segments then and we had a between, I knew I had to fill in B. Filled in all of my domain pieces based upon X. And then I had to go back and look at equations. So I know that this is certainly more complicated than some of the other things that we've done, but I hope that helps you out along the way.